plane we're looking at, well, it looks like this. There it is. And it extends infinitely back, forward, up, and down, but it's tilted on an angle like that. There it is. So what's the easiest piece of that equation to fill in? What's the easiest piece of that equation to fill in? We're now doing fill in the blank math. What's the first thing we could fill in really easily? The point. We could fill in the point. And doing it, as Sujong said, at x equals 0, because we can pick any point we want, right? So what's a great point we could pick? What's the nicest point that you think we could pick?
0, 0, 2.
Yeah, so I want to use 0, 0, 2. So now we have z minus what? 2 is equal to m times x minus 0 plus n times y minus 0. Now we're in the search for what and what? M and n. What is m, Cade? What is m? dz dx. And dz dx is when what is constant?
Y.
That's when y is constant. So we need to see what happens when we keep y constant. Keep y constant and just move. So what's a great point we could start at? It's on the red line. What's a great point we could start our little journey on? How about right there? What's the point right there? What's the coordinate for that point? 0, 1, 0. So if we're on that point and we do a little, let's go for a walk. Here's our little dude. If he's walking that way, is he going up or down? What? Someone said it. Neither. He's still on the xy plane. If you start anywhere, start up here. What's that point right there? 0, 0, 2. If you have a little dude right there, is he going up or down? Neither. So what is dz dx? 0. That's m. N is dz d what? dy. That's when x is constant. So we need a point. Let's say we start up here at that point, right? Let's start right here. I used the same highlighter color. You don't like that? Let's start right. Oh, that just made it worse. Okay. So we're going to walk when we fix x. If we fix x, if we start on that dark point up there, if we start here and we fix x, if we start at 0, 0, 2 and we fix x, what's the x value? 0, right? If we walk this way, our little dude is going to start walking towards this point, right? Actually, we'll go literally from this point to this point. Now, is his journey, is he going uphill or downhill? Downhill. We can actually figure that out mathematically because we have those 2 points. What are those 2 points? 0, 0, 2 and 0, 1, what? 0. So if we want to do dz dy in this case, what's that going to be equal to? Yeah, in this case, dz dy is going to be equal to 2 minus 0 over 0. Exactly. 0 minus 1. So that's going to be 2 over negative 1 is? Should it be negative? It should. So now what can we do with those 2 values? Z minus 2 is equal to m. 0 times x minus 0 minus 2 times. Can we clean this up a little bit? Yeah, we can. Z minus 2 is equal to negative 2y. What variable is not present in that equation? X. And why is that an okay thing for us to have happen? Does the height ever change when you change the x value? No. It doesn't go up or down. We figured that out in the first place. dz dx was 0. It doesn't matter what x is. It doesn't change the height. It doesn't change the height. So it is fill in the blank math anchored by drawing a picture. It's fill in the blank math anchored by drawing a picture. Draw that picture. Yes?
On the test,
Do you know why you feel that way? Because you are so wed to this. Y equals mx plus b.
Oh, I know.
It's only because that's what you're comfortable with because that's what you was drilled in.
On the first step, I think that half the problem.
Of the 12? Great. What is the general equation for a plane? Z minus z naught equals m times x minus x naught plus n times y minus y naught. You got to have that real hard-coded into you. So at this point, let's pick a point. What point do you want to pick? I have the best one. How about 0, 0, 1? 0, 0, 1. That's one of the points. So we have z minus 1 is equal to m times x plus n times y. So now we just need to find m and n. Now, does it say verify that these are linear equations? It doesn't. So we don't have to check all the gaps. We can assume that all the gaps are the same. Yes?
So this is probably a really dumb question.
Oh, nothing's it. Does m equal again? dz d what? dx, and that's when y is constant. I write this down because you will get tripped up if you don't, and you'll go in the wrong direction. So these are the y values, right? These are the y values, right? And these are the x values. So if you keep the same y value, you're going horizontally. If you keep the same x value, you're going vertically. You with me so far? So if we go from 0 to 1, how far up does it go? Or it goes not up, it goes down. So you have 1 minus 0.5 over 3 minus what? Oh, I totally messed that up. You see what I did there? I did the wrong, I was looking at the index, yeah. Correct. So we're going for, well, you could do it that way if I was consistent, but I'm not apparently. Okay, so we have 1, so we have 0.5 minus 1. That's the change in z. You with me so far? And then what's the change in y between those 2 points? 1 minus 0. So we went from these 2 points. So if we wanted to write them out, this could help you. What were the 2 points that we had there? dz dx is when y is constant. Oh, yeah. I totally flipped it, didn't I? Did I totally flip it right now? I did. I totally flipped it. Look, this is where y is changing, not staying the same. So I'd like to pretend that that was done on purpose. Totally wasn't. Totally wasn't. So
It helps to pretend when you immediately say it.
yeah, it does. It does. There's certain moves like that that are really helpful. So let's list out 2 points where y stays the same. Let's actually list out the coordinates, which would be a better thing to do on this one. So how about this point right here? What's the coordinate for that point right there? 0, 0, 1. And let's keep y the same and go down to there. What point is right here? 1, 0, 3. So what stayed the same on that point? The y value did stay the same. So now we can do dz dx, where y stayed the same. So how about 3 minus 1 over what? 1 minus 0. So what's that going to be? 3. So we just, I can almost do math. It's okay. No. I should have been filtering. So now, instead of keeping the y value constant, we need to keep the x value constant. So this was y was constant. So now we need it with x constant. So we could use that point, we could use one of them again. Let's use that one again. I like 0, 0, 1. But instead of going down, we need to go to the right. So if we go to the right one, what's our new point? 1.5, right? So now if we want n, what is n? dz dy, because x is constant. So we have 1/2 minus 1 over what? 1 minus 0, so that's going to be -1/2. So now we take these two values and we plug them in, and we end up with z minus 1 is equal to m, which is, what was m? 2x minus 1/2 y. There it is. So is it really easy, as I just showed by my own mistake, to not pick the correct direction to go in? It is really, really